In homotopy type theory, if we wanted to construct a path between terms, we could use the path induction principle. But what if we wanted to construct a path between types? For that we would need the Univalence Axiom. Let's see how it works. Recall that if we have a path P from X to Y and a type family capital F associating X and Y each with their own types, we can apply the transport function to map any term in Fx to a term in Fy. Now suppose the type in question were the type universe U, inhabited by the types A and B. In that case, f is a function from U to itself. Let's define f as the identity function. In that case, the transport function maps a term in A to a term in B. In other words, given a path from A to B, we can construct a function from A to B. In fact, this function is an equivalence, and we can prove it using the path induction principle, where the base case maps reference A to the identity function of A. We'll call this function that turns paths into equivalences idtoeqv. Finally, the Univalence Axiom says that given this function idtoeqv that maps paths to equivalences, there exists a function UA that maps equivalences to paths. Furthermore, UA is the inverse of idtoeqv, and idtoeqv is the inverse of UA. In other words, the Univalence Axiom says that idtoeqv is an equivalence. Using the Univalence Axiom, we can construct paths between all kinds of types. For example, UA of the equivalence IDA is equal to reference A, and UA of F composed with G is the path UA of F composed with UA of G. And if we apply UA to the inverse of F, we get the inverse of UA of F. We now know how to use the Univalence Axiom in homotopy type theory. Thanks for watching.